Okay. So today I actually just went through the whole problem, but we will go through it again to make it stick. Okay. So this is the problem that we're looking at. It says that given an array A of zeros and ones and a value k, which indicates that you may change up to k values from 0 to 1, return the length of the longest continuous substring that contains only ones. Okay, and right here we have all of the ones, and the largest continuous we can do is from here all the way to here, which means that it will just replace these zeros. Let me actually enlarge my screen so you can see my whiteboard. Okay, so from here, if we replace these two zeros, we'll have 1, 2, 3, 4, 5, 6, which is actually our answer. And we know that our k, the amount of zeros that we can change from 0 to 1, is 2. Okay, so the way we're gonna solve this problem is using sliding window. Right. First, we'll have a hash map to essentially keep track of our count. Initially, they'll both our zeros and one will both start off at 0. Okay, and from here we're gonna have 2 pointers. We're gonna have one as our start, as our S, as you can imagine, and another one as our E, which will essentially indicate for our end. All right. From here, what we're gonna do is we're gonna say, hey, our number of one count incremented to be 1. Right. So now we have 1 in our count. Right. And so from here we go to the next one, we increment our count of 1 to be 2. Okay, so we have 2 ones and we have 0 zeros, like essentially 0 zeros. Okay, so what we're going to do is we're going to keep incrementing our count of 1. We're going to keep incrementing and we're going to see what will happen to 0 and how we can essentially indicate whenever that we're making what's it called, a change from 0 to 1. Okay, we go to 1, we go to the next one, we increment our 1 to essentially be now 3. Okay, we go to the next one. Well, now we're here at 0. Okay, so from here we're going to increment our count of 0 to be 1. Right, so how do we indicate that we have only done exactly 2 changes? The way we can do that is we have to look at our size. Right, so this is where end is right now. The way that we can get our size is we can say size is going to be equal to our end index minus our start plus 1. That's how we get our actual size. We can remove the let. Okay, so what this means is, like, if we have all the index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, our current E is right now at 3. If we subtract 3 minus 0, it's going to give us 3, plus 1 is going to be equal to 4. So right now our size is equal to 4. Right, as we can tell, 1, 2, 3, 4. We have 4 elements that we have encountered for. And what we're going to do is we're going to keep a track of all the ones that we have essentially counted for. All the ones that we have encountered for. And in this case, it's going to be equal to 3. So if we subtract 3 from our length of our engagement, that means that we have done exactly 1 replacement of 0, which is true. We essentially now have a length of 4. This is currently our longest continuous substring that we can have, that we have done exactly one replacement, which is the first 0 that we've encountered. Right. Okay, let's keep going. When we come here, we go to E. Now we increment our count of 0 to be 2. And if we increment our count of 0 to be 2, we update our length, our size, to be 5, right? And our maximum number of ones will still be 3, which will indicate that we have done exactly 2 replacement, which is still within our inbound. So currently, our maximum continuous string that we have right now will be equal to 5, right? Which is from here all the way to this right here. Okay? And from here, this is our previous length that we have. From here, we go to the next 0, which will update our 0 to be equal to 3. And we will update our size from 5 to 6. And our longest long as our number of count of ones will still be equal to 3, which will indicate that we have done exactly 3 0 replacement. Now from here, we can immediately tell that our 3 different replacement is greater than our k. So what that means is that we have to reduce our size, right? And we have to get to a point where our k is within that bound of our number of replacement is within our bound of k. Okay, the way we're going to do that is we're going to move our windows, our starting window. So currently we're here with E. We're going to move our starting window over. So we're going to say this S will move over here. This S, when it moves, so what we're going to do is we're going to reduce our size of 1, which will now come down to 2. Right, and which will also reduce our size of 5, but now our number of counts of 1 will be down to 2, which will still indicate that we have done 3 replacements. Okay, we come here, we reduce our size of 1 down to 1, we reduce our total size from 5 to 4 minus 2 minus 1, right, because we have deducted our 1 value, which will still mean that we have done 3 replacements. So we have to keep going until our value of replacement is lower than k. Okay, we keep going. Now we come here. We'll also remove our 1 to now be essentially 0, right? Because we removed our last one, and our size will be 3, and our number of ones we have is 0, which will mean that we have done 3 replacement. We keep going. So we move from here to here, which will mean that we reduce our count size of 0 to now be 2. And if we have 2 minus 0, because we no longer have any ones because we're essentially here now, our number of replacement that we've done is essentially 2, which was true because we have done this replacement and this replacement, right? And that has also decreased our size down to 2. Okay, so let's keep going. Now that we are within that bound of 2, 0 replacement, we can move our E over. So we move our E over here. This is our E. Now we can increment our 1 back to 1. Our size will now be 4. Well, this is 6. 6 minus 4, which is going to be, what's it called, 2, plus 1, which is going to be 3. So we're going to have 3 size. Our number of ones is going to be 1, and which will mean that we have done exactly 2 replacement. Okay, we come here. Our number of ones will be changed to 2. 3 minus 2. Well, our size will increase to 4. Minus 2 means that we have done 2 replacements still. Come here with our E. This is E. We increment our size to 3. Our total length will change to 5. Minus 3, which will mean that we still have 2 replacement, which is the 2 zeros in the front. Okay, we come here to E. We say, hey, our size has changed to 4 now. Our total count of 1 has changed to 4. Our total size will now be 6 minus 4, which will mean that we have done 2 replacement. Okay, when we come here to the next E, our 0 will be updated to be 3, right? And if our 0 updates to be 3, but our number of ones does not, our size will be equal to 7 minus 4, which will be equal to 3, which means that we have done 3 0 replacement, which is over our allowed k. So now what that means is we have to move S over. So S will move from here, our indices of 4, to here, which will reduce our number of zeros to be 2. And now if we would do 7 minus, well, our size will decrease to 6. 6 minus 4, which is going to be equal to 2. And that is within our inbound, and that is our answer right here. So we'll update our maximum length or continuous length from 5 to 6, and we return 6. So that's how we get our answer. Okay, so from here, I'm going to do a little bit of pseudocode of how the code will look like, and we can go from there, and we can actually code this up and see the result. All right. Okay. So from what we talked about, this is going to be a little bit of pseudocode. We're going to have 2 variables. So we're going to have a couple of variables. We're going to have our max, which will be equal to negative infinity as a start, and then we're going to have our let start, which is going to be equal to essentially 0. We're going to have our hash map, hash count, you can call it, which is going to just be since we know our essential keys is going to be 0, for 1 and then 0 for 0, right? The total count. And from here we'll have our for loop for let end, also starting at 0, end is less than our array dot length, end plus plus. Okay. From here, what we're gonna do is we're gonna update our hash map count. So we're gonna say we're gonna grab the the number. So we're gonna say num is gonna be equal to our array at index of end. I should probably write with a red marker. Okay. And from here, what we're gonna say is we're gonna update our hash map count. So we're gonna say hash map hash count at index of num is going to be plus plus. All right, and then we're going to now get the a few things. We're going to get our number of one count, which is going to be equal to our hash count at index of 1, right? And we're going to now get our size, which is going to be equal to our end minus start plus 1, and we're going to say while our size minus our 1 count is essentially strictly greater than our k allowed. We're going to do a few things. What we're going to do is we're going to reduce our size count, and actually instead of doing it like this on our while loop, what we're going to do is we're actually going to take our end minus our start right here plus 1, and put this in a while loop, because what it's going to do is this variable, our start, will keep updating. Okay, from here we'll grab our start number, so we'll say let what's called s num, which is what indicate for our start number. We'll look at array at index of start, right? And then what we're going to do is we're going to deduct our total count from there, which is going to be our hash count at index of s num start minus 1. Okay, and this is going to reduce our size, which is also going to and another thing I want to do is, instead of doing count right away, since we're going to be updating the hash map directly, what we're going to do is we're going to say hash count of 1, right? Because as these hash map updates, we want to also update our while loop indication. So we can actually just remove this right here. Okay, from here, if we get out of the while loop, what we want to do now is we want to update our maximum length, which is going to be, just imagine it over here. Let's just imagine it here. This pen is dead. I need to get a new one. You can just imagine it over here. We'll write it in the code, which will make it a lot more clear. What we want to do is we want to say our maximum count will now be equal to math.max of our end minus start plus 1, or whatever that we currently have as a max length. And at the end, we can simply just return our max. Okay. So that's essentially the whole solution. And the time complexity for this is actually going to just be O(n), since we're using sliding window. And as far as space complexity, since we know that our value only be 0 and 1, it will actually just be constant space, right? Because we know our value is going to be 0 and 1. It's not like alphabet letters that will essentially increment our count size by the alphabet or by the string. But this would be our time complexity and our space complexity. Let's go. So I'm going to get to the computer now, and we're going to code this up. All right. So let's go to REPL IT. call this function function get longest range. I'll call it. I know that we'll have our array and we'll have our k. Oh, I am not sharing that screen. Okay, there we go. So all I wrote was our function name, and which is going to be get longest range. Okay. From here, we're going to have a few variables. We set our max, which is going to be equal to our negative infinity. Right. We're going to have our hash count, which is going to contain two variables: our 1 at 0 and our 0 at 0. Right. The total count that we have, and from here. What we're also going to have is our start, which is going to start at index of 0. Okay. And from here we can essentially start doing our for loop. So for let end is going to be equal to 0, while end is less than our array dot length end plus plus. First thing we're going to do is we're going to grab our number, which is going to be equal to our array at index of end. And from here, what we're going to do is increment our hash count of num plus plus. From here, what we're going to say is we're going to now determine to reduce our size. And the way we can do that is we'll say, hey, if our end, I'm going to put this in parentheses, if our end minus our start plus 1, just put it in parentheses so and make sure it executes in the order that I want to, is plus 1 minus our hash count of indices of 1, right? Our hash count is strictly greater than our k value, then we know that we want to reduce our window size. And the way we can reduce our window size is essentially saying our hash count at index of our array at start, right? And then we're going to do minus minus. From here, we can essentially increment our start to be plus plus. What this is going to do is we're going to grab whatever value is at start, subtract 1 from it, and then increment our start over, which will essentially update our while loop. Okay. And from here, what we want to do is we want to update our max count, our max value, which is going to be equal to our math down max, which is going to take our max value or our end minus start plus 1, right? So what this is going to do is going to indicate our initial range to be negative infinity, which will automatically update if we are within inbound. And from here we can essentially return our max, right? So this will always essentially be updated, even if we have exactly one count. Okay. So this is our whole algorithm. Let's test it out. And we'll pass in the array from the problem. And then we will also pass in our k of 2, of like 2 replacements that we can do, and we'll console log it. Cool, we got 6, exactly as we expect. Now let's make sure this is exactly what we expect. Let's do this one right here, and we're expecting 9. So let's say if we were to pass this in, and we have a replacement of 3, we get 9 as exactly as we expect. So that's basically the whole algorithm. And yeah, thanks for watching. Subscribe if you want.